are talking about polynomial word problems and solving them using polynomial operations. And we have an example here. A rectangular swimming pool is bordered on one side by a deck. A contractor is hired to build a walkway along the remaining 3 sides of the pool. So here's the deck, and here are the other 3 sides. The width of the walkway is the same on every side as shown. The width here is x, the width here is x, the width here is x, so that means they're all the same width. Part A says, write a polynomial that represents the total area of the pool and the walkway. So we're going to go back to our area calculation, and we know that area is equal to length times width, and we're calculating A right now. As we look at this, we know that we don't really care about the deck, we care about the pool and the walkway. So the length of this is the long side, and we know that this is 40, and then the sidewalk width is x. So the length of both of them together is going to be 40 plus x. And because we know it's multiplication, we are going to substitute this in using multiplication. So I have to make sure I use my parentheses. The next one is the width. And the width in this case is the width of the pool, which is 20, plus the walkway again down here. So it's the walkway x plus 20 plus x plus 20 plus x. So x and x is 2x, so it's 20 plus 2x. And we know that we're calculating area here. And whenever we do multiplication of polynomials, we know that each term of the first polynomial needs to be multiplied by each term of the second. So we start with 40, and we say 40 times 20, 40 times 2 is 80, and then we have to add the 0 because we're multiplying by 0, so that becomes 800. And then 40 times 2x, 4 times 2 is 8, and then we have to add the 0, so that's 80. So that's plus 80x. X times 20, that becomes 20x, and x times 2x becomes 2x squared. And now we can combine our like terms. Because polynomials we want to write with the highest degree or the largest exponent first, I'm going to start with my highest exponent, which is 2x squared, and I don't have any other x squared terms, so I can write down 2x squared, and now I'm done with that part. The next one we have is x, so we're going to add x, add all the x's. We have 20x and 20x. Or excuse me, 80x plus 20x is 100x. And then last, we write down the constant. So we wrote down those, and now we write down the constant because we only have one of those. That's plus 800. Now it says, find the combined area of the pool and the walkway when the width of the walkway is 5 feet. So in this case, we're going to look to calculate B, and it says that the width or x value is going to be 5. So we want to find the area of the pool when x is equal to 5, and we can substitute that into our equation down here. So area is going to be equal to 2, and then we're going to substitute that 5 in there, plus 100 times that 5 plus 800. And we're going to substitute that value in. So we're going to substitute the 5 in. And we get 5 squared is 25. 100 times 5 is 500. And 2 times 25 is 50. And last, we have 500 plus 800 is 1,300 plus 50. So we have 1,350. And that is the area of the pool. And that is measured in feet. So that's got to be feet squared because we're talking about area.